Okay, so I just ended the other video because I felt like it was getting a little long, but this is the last slide before I move on to the next section, so this will probably be a pretty short one. But there are other types of AC waveforms outside of sinusoids, and these are the three major ones. The first one is a square wave, which you'll actually see quite often. Square waves are pretty easy to generate. They show up all over the place, and outside of sine waves, they're definitely the most common other type of AC waveform. You will also see triangle waves, which obviously they have some practical implications, and you can use them if you want to, generate some kind of a linear ramp. You could make this half period pretty long to generate just a long rising edge to test different types of circuits. And the same goes for the sawtooth wave if you really just want to try and test if you want to just test a rising edge from one voltage value up to another voltage value, you can set most function generators to output any given one of these types of waveforms for different purposes. But the reason why we study sine waves almost exclusively in a class like this and in other classes is because they have a very special property when we put them into circuits. Well, it's not very special, but it's unique to the sine wave outside of these other functions. First of all, they're pretty easy to define, right? So when we wrote the sine function v of t, we can define it by its amplitude, we can define it by its frequency, and we can define it by its phase. And so what's special about sine waves is when I put a sinusoidal voltage source into a circuit, and I go to measure the voltage at another node in the circuit, or I go to measure the current at another node in the circuit, there's only two things that change from this source, function here, this v of t. Those two things are the amplitude and the phase. So at any point in the circuit, let's say this is pretty off topic for this slide, but let's just say I've got, a source, and I have a resistor, and I have another resistor here, and this is my Vs of t, which is basically Vm sine of omega t, and I'm interested in figuring out what V2 of t is or something. The only difference between Vs of t and V2 of t, the sine of omega t is going to be all the same, but what is going to change is going to be the amplitude, we'll call this Vm2, and the phase. Those are the two things that are going to change. So we're going to look into some circuits pretty soon, but I have to cover some more topics first. But we're going to see that the reason why we typically talk about sine waves is because it's pretty easy to define them in terms of just their amplitude and their phase, since nothing else changes from one node or one voltage or one current to the other within a simple linear AC circuit. Okay, so there are other types of waveforms, just wanted to point that out, but the reason why we use sine waves is because they are easy to represent by only their amplitude and their phase, and that leads me right into the next topic for the next video. So I'm going to go ahead and end this video right here.